Hi, so my name is Satyam and this is day 4 of an interview prep journey, and in this video we will solve problem around three path finder in a binary tree, right? So let's first understand the problem. So basically we need to create a function called path finder which takes in the root of a binary tree and a target value. The function should return an array representing a path to the target value. If the target value is not found in the tree, then we can return null, and you can assume that the tree contains unique values. Okay, so first let's understand what exactly problem is asking us to do, right? So yeah, so basically let's suppose uh, this is a binary tree, and we need to and our target value is f, so which basically uh, and we need to find a path uh, to the target value, right, from the root basically, right? So basically we need to find a path uh, which will start from the root and end till its target value, right? So yeah, for example, if we if let's suppose if f is our target value, right, we need to find a path for this, right? So we know that, okay, this is a path, so a c f is a path. Okay, so the output will be basically we need to return a path with like in an array, so a c f. So basically this we need to do, right? So basically we need to find path till our target value. Let's suppose if f as target, then our path will be acf, right? So we can return array of acf. If let's say b as a target, then we know that a and b is a path, so we can return a and b as an array. Let's suppose if value is not let's say present in the binary tree, we need to return a null, right? So basically let's say p is a target, uh, we could not able to find p in our binary tree, so we will return a null. So basically this is the edge case that we need to take care for when we are solving. Okay, now so for solving this problem, let's first understand a few things. Okay, so what I did here is I visualize in a very detailed way, right? For example, if f is a target, right, we can imagine, okay, that okay okay, that because d is a leaf tree, right? It does not have a left and right, so we can just imagine, okay, this is none null, this is a none null, and this is also null, because I did not um, add here, because um, f is our target, we know, and we don't need to find, or maybe we don't need to like basically find um, bottom children, because we have found our target node, right? So that's why I did not put null here. Okay, so basically first let's suppose, because let's focus on the smaller tree, which, right, let's see if we can understand, or maybe understand approach to solve this. So let's suppose this is a tree. This is so it has one head called c, and it has a left and right node called f and null. Let's suppose we need to find a target, right, f. Okay, so how can we solve this, or right, or how can we think that what will be the path for this? Okay, so because let's say if we have, let's say we have found this f path, right? So uh, the the output will be cf, right? This is the path. Okay, so basically what we are doing here is we are checking that for given node, first check right and left, right? And if right is true, which or maybe if right we found our target value, which means we need to ignore the left value, right, and form a path from there. Okay, so that's what we are doing here, right? So um, yeah, so remember this, um, we will solve this by understanding this thing. So because this is a binary tree, and we need to find a path. So whenever we are working like for, let's suppose if we need to determine the path, we need to find a path, right? It's usually, or it's best to use depth first recursion, right? Because it's very easy to solve by recursion, right? Okay, so we know that okay we will use recursion, right? And of course we will use depth first approach, and because recursion or function has their own implicit stack, we don't need to create stack. So yeah, this was some things to remember. And so because we are using recursion, so what will be the base case, right? Because we need to take care of the base case whenever we are working with recursion. So yeah, so we know that okay, uh, if we found our target we don't need to continue, right? So first our base case will be if match, right? We just need to return, we can return a array array of the target, right? So of the target value, right? Okay, that's and why are we uh, returning as array? Because we know that uh, at the end we need to return array, right? Array of node, right? So that's why we need to return value with array, right? So let's suppose we found our target node, we can just return array containing its value, and then as we go above to find a path, right? We can just get the root value and add it here before, right? So so this is the approach that we will do. Now let's translate this to our code. Okay, so yeah, so first let's write our base case. So there are two base cases basically. um, if root equal null, we will return null. If we found target, we will return array containing its value. So return root dot val. Okay, now what we will do is find a first left path, right? So we can do path finder root dot left, right? And same for right path, right? Now we will check if, let's say, if left path is true. So when it will be true, it will it the uh, this here will only be true if we found our target, right? So this will run basically, and the output will be value containing array, right? So I can just add a condition. If, let's say, if left path is true, is or maybe is not equal to null, what we want to do is uh, return mm, 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 root dot value, right, and left path, and we need to spread this, right. Else, if we does not found a target value, we just need to return null, or this is fine. I think we can basically return null at the bottom, right. And again we will add same check for right path. If right path is not equal to null, right, which means it has some value, and which means it will be the array containing value. So if right, so right path, right, it should be right. Yeah. So let's say if it does not found uh, any uh, any any if it does not found a target in any left path or right path, we will return null. Okay, so this looks fine. Okay, let's rewind or revise. If root is not, if root equal to null, we can return null. If we found a target, we will return its value containing array. Okay, then we are recursing, then we are calling pathfinder and checking for the target. If if it is not equal to null, which means it has some value, so root dot value left path looks fine. This looks fine. Let's test it. Okay, actual null. Okay. Okay, we need to mention target. Okay, now let's check it. Okay, so we have completed this task, but let's talk about the time complexity and the space complexity. Complexity would be constant, right, because we are using handful variables. So space complexity would be O1. And what of the time complexity, right? We are calling this function um, by uh, number of nodes, right? So let's say if in a tree there are 5 nodes, we will call this function 5 times, right? This we know. But because we are using this spread operator, right? So in JavaScript, it basically copy the array. So this here also will take O n time complexity, right? So actually, because of this, right, the time complexity would be O n square, right? And complexity O n. Okay. And can we reduce, let's say, can we reduce time complexity to O n? We can do it. What we will do is create our helper function. So let's say if this is a pathfinder helper, right? We can just call right. This should be same. Okay. Now call here So basically we need to remove this line, right? So how can you do this? Okay, but we can use push, right? Basically we can push to this array, right? But because we need to because if we push, right, uh, the the because push basically add items to the top, right, or basically top, right, after, but we don't want that, right? Because let's say if we found this f target node, right? So this here will be f, right? Again we have come here, and this would be, if we push, right, this would be c, and then again a, right? So this would be our answer, which is fine, but we don't want that. We want a c f, right? So we will use push basically, but first let's use that. Okay, so left path dot push, so we are pushing into the array root dot value, and we will return left path. It is very necessary to return, right? And same for here. Okay. Okay, now here we are getting the result, but we are getting the result in reverse order. So basically we need to reverse. Okay, so I mean we can use reverse here also, but because reverse is also take on time complexity. If we use in here, so it would be n square, right? So that's why we are first getting our result, then we are reversing, right? So the all the so total time complexity would be, if we talk about unsimplified, this would be O n plus n, and if we simplify this time complexity, it would be O n, right? So yeah, result dot reverse, right? So let's say, no, because it may have the result can be null, right? So we need to add check for that. If result equal to null, we will return uh, null. Okay, so we have added this check. So yeah, now else we can just return result dot reverse. Okay, test it. I don't want to check. Okay, ABA AEB. What is this? Console of, okay, no, maybe it should call this function. I don't know. Yeah, why? I know how it is working, but yeah, this is fine. So we have completed this task, and we have reduced our time complexity to on, right? Before it was on squared. So yeah, this is the best solution, I think. Yeah, thank you for watching the video. Bye bye. Bye bye.